our variable. Number 2, write the hypotheses. Now, I never really particularly cared for the order that they're given in. You've got H0, and you've got H1 or H alternate. I don't know which one your textbook uses. It doesn't matter, they both mean the same thing. Just like we talked about last week, these are going to be opposites of each other. Which is the one that your experiment is trying to support? Good. This is the one you're trying to support. This is the status quo. But you're right, you're going to assume this is true and try to disprove it with your data and believe that this is true here. Yes. Exactly, you're trying to disprove this one, which will then support this one. Now we're using the word prove very carefully here. We're not proving anything. It's all within a set level of confidence. We could be wrong, there's your error. And we'll talk about that momentarily as well. Okay, so what are we trying to show right now? That the new vaccine works. Beautiful. That in words, that the new vaccine is working. I.e., how do we define working again? Lowers flu rate, yes? Let's put that into symbols. I'm going to put the letter P, which is the proportion of those getting sick on the vaccine. We want to show that that lowers the flu rate. Lowers. Lowers. Use mathematical symbol. Lowers. Less than. Is less than. We want to make it less than. We want to get less than. Right?
But P would be greater than.
But P is people that are on the vaccine. We want, no, I see what you're saying, Michael. You're saying P, the population should be greater than. Yes, I'm going to say it a different way. The people, because we've defined the variable like this, the proportion of those with the vaccine, their flu rate is going to be less than that of the general population, which is, what number? 12%.
Don't say more than or equal to 12?
Well, that's a good question. Should we say less than or equal to 12? Or
no, but I say more than or equal.
No, it can't be more than.
No,
If
we're
it's,
supposed to prove the opposite.
I haven't gotten there yet. You're 30 seconds ahead of me. That's what we're trying to support. The opposite of that, of course, would be that it's more than or equal to 12. That's what we're trying to refute. We're trying to refute that the vaccine is ineffective. Now, the vaccine being ineffective means that the people on the vaccine would get sick at 12%, just like everybody else in the population. This would be the worst case scenario. We give people the vaccine and they get sicker at greater than 12%. So obviously, these are the cases that the makers of the flu vaccine don't want to have happen, correct? They do not want that to happen. Because if that happens, their vaccine gets thrown out, they spend all these tens of thousands of dollars on research. Now this happens all the time, of course. This is what research is all about, is running into dead ends and trying something else. But we want to see if we can disprove this. Because if we disprove greater than or equal to, we've by default shown this has to be true. Because one of these two things is true, yes? The flu vaccine, excuse me, the rate of flu with people that have gotten the vaccine is either the same as the general population or it's less. Do you guys agree with that, yes? These are mutually exclusive. Either it's less than 12% or it's greater than or equal to 12%. If you can get rid of these two, that means this has to be true 95% of the time, 95% confidence. Skylar?
Can we put them in words too?
You totally can. So here, the proportion, well there's two, before I start writing, there's two ways you can think about it. Since you define the variable here, you can actually get the words from the statement. So P, the proportion of those getting flu with the vaccine is less than 12%. So you can pull it, that's why I added that step right there in step whatever it was 2, defining the variable, so that you can look at your hypotheses and right above it and extract what you need. So the proportion of flu with the vaccine is less than 12%. I mean, that's essentially what it's saying in symbols. Fair?
Yeah.
And then this is going to be the opposite of that. If it's not less than, as Deanne said, it's either greater than or equal to. So the proportion of flu with the vaccine is greater than or equal to 12%. The beauty of the symbol, the beauty of the little p, is that it allows you to wrap this whole idea up and drop it into a quick little inequality. This is our guide. This is our guide. This is our guide. So now, if I may go back to this curve that we started drawing earlier, I'm going to take some stuff off and add some stuff to it to make it look like last week's curves that we were looking at, if that's fair. So, take this away. Because we know that 10.1% has to play in. We're going to get to him. But before we even start the experiment, we know we have this curve right here. We know we have this curve. And this is the people who are going to get the flu without the vaccine is at 12%. Now we're trying to see if the people that do get the vaccine fit on that curve. And that's the problem. If the people that get the vaccine fit on that curve, that means the vaccine's not working. If they fit nicely on this, the meat of this curve, that means they're getting sick at the same rate people without the vaccine are getting, so why bother getting the vaccine? Basically, you're injecting sugar water in your veins. So if they land right there at 12%, that's bad. If they land over here, is that bad? That's potentially bad too, isn't it? Because that means they're getting sicker. Maybe a live virus, they're getting sicker. Without going into biology, they're getting sicker. If they're over here, is that bad? This is bad. This is a virulent strain that you're injecting. Now you're just injecting them with terrible, terrible crap, and you shouldn't be. You should lose your license. Okay, now how about over here? How about over here? They're better than average, but is it?
Is that with the margin?
You are better than average, but are you
No, yes,
significant? Good, good. Yes. So where do we have to go to be significantly better than average? Now, I'm asking this question not for an exact answer, but how far down do we have to go? What do we have to do to the curve?
Is it like with
Yes, it is that, but think about how far down we have to go.
ish?
Boom! That's what I was looking for, Tim. We have to get down to a point where 95% of the curve lives here, and 5% of the curve lives here. This is that critical region. Now there is a z-score that goes with that. We'll come back to that momentarily. You don't have to worry about it though. You don't have to worry about it. But the normal can find it for you. The program I gave you guys last term, or the charts you guys used, will find that. I think it's negative 1.645, I think. But the p-value will also tell you that, and that's what I want to talk about next, is how to get that number that tells us. Because the p-value will tell us, did we land here, or did we land here? If the p-value comes back at less than 5%, that means we landed over here somewhere. If it comes back at greater than 5%, it means we landed in here somewhere. Does that make sense? This is the crossover from last week.
So that means it's significantly better.
Yes! If it's less than 5%, that means the vaccine is lowering flu rates statistically significantly. Now, I'm not going to get in a fist fight whether 1.9% is practically significant, because it might not be, right? It might not be. It might not be practically, but it is statistically significant. And YouTube world, please understand that. Statistical significance isn't always practical.
10.1 was?
10.1 was the sample proportion that we got. 101 out of 1,000 people got sick.
What did you just say was significant?
I said I'm not going to get in a fight whether it's practically significant or
What
not.
number did you throw out?
5%.
1.9%?
1.9.
Which is the difference between 12 and 10.1.
10.1.
Yeah, yes, that's okay. All we're checking for is whether it landed here or whether it landed here. And then you guys, as you get into your individual fields, you get this fight about whether it's practically significant or not. You guys all kick my ass. I don't want to fight with you about that here.
To me, logically, it doesn't.
That's okay. But you're thinking in terms of pure number. You're thinking in terms of pure number. We haven't adjusted for standard error. That's what the test is all about. Fair enough so far? Are we happy with it? We're not happy with this. Are we content with this? Do we see what you put what you want to test here, you put everything else up here. Fair? Decent, maybe. Okay, good. All right, good. So, next step, define the two types of error in context. So this is type 1 and type 2. One of these will be possible to make when we're done, but it depends on our conclusion, and that will make more sense in about 5 minutes when we get to that. What's a type 1 error? What do you remember about type 1 errors? Good! It's a false positive. It's a false positive. What does a positive test result mean again? You can go with a 243 definition or a 244 definition.
Positive for what you're testing.
Right. So if you're testing that a flu vaccine is working, you're going to say it's working. But if it's a false positive,
I think it's really not.
that means you said it's working, but it really isn't working. Which means you gave people this vaccine, you got a p-value that's less than 5%, and you go, hot damn, vaccine works, less than 5%, we're over here, less than 5%, we're over here,
Break out the needles.
break out the needles, and the champagne maybe, We got a vaccine that works. But you never know with 100% certainty if it works or not. There's always a chance you're wrong. This is the way to be wrong in that case. If you get a small p-value, you can still be wrong. You're already wrong 5% of the time, aren't you? Excuse me. 5% of the time, you are going to be wrong by statistics. Probabilities, I should say. So, I just heard it defined. What was the definition of again? What's the type 1 error in context? I'll get you started. Saying the vaccine works, comma, when it doesn't. That is one way of being wrong. Keep that in the back of your mind right now. I'm about to ask you which one of these is worse, whether a type 1 or type 2 error is worse. And we'll come back to that. Type 2 error, false negative, which would mean that, how big a p-value did we get? A big one, greater than 5%. So we put the champagne away, put the needles away, because the conclusion is that the vaccine does not work. Could you be wrong? Of course. So the context would be saying the vaccine doesn't work, comma, when in fact it does. You can miss that. That's a false negative. That's a false negative. Now, of course, you're not going to know if you're right or wrong. That's the problem with probability. It's the problem with prompts. It's the problem with the probabilities. The only thing you have is this test to decide. That's the only thing you have is this test to decide. More on that momentarily. We'll talk about how we can mitigate these errors. So we got a false positive saying the vaccine does work when it doesn't. And we got a false negative saying the vaccine doesn't work when it does. Next point, and this is something I want to get you guys used to. Which of those two do you think is worse and why? There will not most likely be unanimous agreement to the answer of this question. Okay? So I want to hear what you guys think. What would be worse? Saying the vaccine does work when it actually doesn't. Or saying the vaccine doesn't work when it actually does. And I want to hear, this is where it gets unmathy. It gets into your personal opinion about this. What do you think? Kate, you're going to say something, I thought.
Yeah, I'm kind of on the fence because
Okay.
if you're saying it's a type 2 error,
Mm-hmm.
saying that it doesn't work when it really does, you're throwing it away with all the money that you spent, and you're able to, help the population and lower the flu portions. However, if you're saying it works and you give it to everyone, you could actually be increasing the rates.
So it's tricky. This is tricky with this one, yes? It's tricky because if you're saying it does work, when in fact it doesn't, you might be raising flu rates. Because if you say it works when it actually doesn't, that means the flu rates are still here. Now, technically speaking, they're centered on 12%, so you hopefully wouldn't be. You probably won't be raising it. The chance of raising it is just as unlikely as the chance of lowering it randomly. I like your point, though. Did anybody else different? Renee, I thought you. Go ahead. No?
No, I was type 2.
Type 2 is worse. So withholding a true vaccine. Probably, going off what you guys are thinking, you got me thinking about it too. If the strain is extraordinarily virulent, it's going to be terrible to withhold a potential cure for it, or a potential lessening for it. So I agree. So it would be nice to minimize the chance of that error, wouldn't it? More on that in about 10 minutes, about how you minimize chance of type 2 error. Good. Other opinions? Michael, go!
I mean, what you're getting at is that there's really no right answer.
Oh God, no, there isn't.
They both have, their pros and cons, and so
That's very, very true.
That's why nobody will really agree on it.
Very true. Now, I think in some situations, and I'm curious to see how this shows itself as the course goes on, sometimes like a type 1 error is clearly worse than a type 2 error. For example, a recall on a car. How many of you guys have had something on your car recalled? Yeah, a few of us, right?
I got one right now.
You got one right now. So does our Jeeps. Our Jeeps do too. Our Jeeps have a fuel tank.
Yeah, that's what.
The fuel tank rupture. If you get a rear end collision on a Jeep like from like 95 to 214 or something, I forget what the years were, but both of ours fall in there. There's a potential to create a spark which could ignite the gas tank.
Yeah, that's like that Ford truck.
The Pinto from back in the day.
No.
Remember that?
There was a big case in Manchester.
Oh, gotcha, exactly. Now the thing is that those cases could very well simply be outliers on an otherwise normal curve. But they're willing to risk that, obviously, especially what happened to Ford back in the 70s with the Pinto, when gas tanks were exploding kind of regularly, and they decided it was cheaper to pay out the lawsuits than to fix the problem. That was ridiculous. But they'd rather err on the side of a false positive. Bring your car in, let's change it out or check it. Most likely it's nothing. So they're actually allowing for more of a false positive, because a false negative would be catastrophic, correct? If there was actually a problem and they ignored it. So, and the reason I bring this up, and this is only for your future research and reference, we always operate this at 5%, yes? If we're willing to accept larger false positives, you can actually move this back and lower your confidence. That's okay, and you'll see, Michael's like, wait a minute, why the hell would I do that? Hold that thought. Sometimes you want to do that. I'm not, you were just taking that in.
I was thinking about something else.
Oh, you're thinking about something else. I saw your head move this way when I went, you can lower your confidence, because me and JC just had a conversation about how you don't want to do that. But this is a different context. How would you rather be wrong? Would you rather be type 1 or type 2? Sometimes you'd rather be type 2 or rather be type 1 depending on context. That's why I'm curious to hear what you guys say. Harrison, go ahead.
False positive in this case.
Go ahead.
If you eliminate the flu, you're not going to make any money off the vaccines.
Oh,
So if you
careful.
got one that's too good, you don't want to.
Careful, brother. Careful. Talking to a hippie here.
Well, that's,
You're talking like the anti-capitalist.
yeah,
So careful.
that's what some of these big companies do.
I know you're right. This is why you have 10 ED drugs for every cancer drug. I understand that. It also pisses me off. But you're right.
Yeah, no,
You're absolutely correct. Thank you for that extraordinarily honest.
That's what I was thinking.
You were thinking of that, Michael?
And you get more criticism for doing type 1 because, because
You wasted my time.
you wasted my time, you took my money,
You
and
took-
you were wrong
You
about it.
stuck a needle in my arm.
Yes. Oh, and we also made sure that you didn't get exploding diarrhea because of our drug. It's okay though. Just wanted to make sure that you didn't explode diarrhea all over your loved ones. I get it. I love what you guys are saying. And it's taken to heart. Trust me, it's taken to heart.
The diamond market's an inflated market too.
Oh,
False
brother,
positive
there's
right there.
plenty of
Yeah,
markets
it is,
operate
yeah.
on fiction. But yeah, I wasn't trying to get pissed
No,
off.
it's
I'm
not
just saying that
that.
what you said is true, and that's why it kind of stings a little bit. I thought I saw a hand over here. I thought, Renee, go ahead.
Is it a difference between collecting the data and interpreting the data?
Of course! And that's why I want to get to the next step, which is actually getting the result and setting this margin of error up and then interpreting and seeing only what we can say about the interpretation. Thank you. Thank you for that. Is that
Just sometimes throwing out the data and starting over again
With-
when we season.
we hope not. Sometimes you should throw out data if it's too deviant or too outlierish. You won't have outlier data with proportions. You can't. You can't have outliers with proportions. It either got sick or you didn't. It's not like this guy got a fever of 105 and this guy got a fever of 101. It's nothing to do with that. It's just you did or you didn't. Now you might want more specificness. That's where the means come in. That's what next class is all about, is getting into the averages too. But right now it's just yes or no, off or on. Go, JC.
Okay, so a question. When you say the vaccine works when it doesn't,
Yes. That works.
what percent of the time is that?
Well,
Because
on average, we're talking about how many get sick in the population. Not percent of the time, but just percent of the overriding population. So here comes the annual flu that we're targeting in this strain. On average, when that strain comes through, 12% get sick. We want to lower that. So it's not so much a time element as a frequency element. Is that okay?
So it's more frequent that the vaccine works when it doesn't. Like saying
The-
it works but it doesn't.
Saying it works when it doesn't is a type 1 error, yes. Claiming
That's
that...
not like we can't say 100% of the time.
Oh, I see what you're saying, JC. I'm sorry. In other words, either the vaccine works or it doesn't. We don't know which it is. We're trying to develop data that shows that. What Renee was just saying right there. You make a claim based on, you know what, can we hold that question until we actually run the numbers? Let's run the numbers and see what our interpretation is, shall we? I think that's the next point. The next point is to actually set the numbers in motion, answer Stacy's question here before, and it actually ties into JC's question beautifully. All right, here we go. Which distribution should we use? Now you got to remember, I drew a bell curve over there on that board, yes? All right. So if I'm drawing bell curves and we're studying